Okay, YouTube, today we're going to see how we can wind transformers for Smps. As one can see, I have all the plans made up here. I still have to etch the PCB, but just showing off that plans have to be made before winding the transformer here. And this one we're going to have it wind, and I'm going to show how it's going to be done. Mind you, this is an Smps, a switching mode power supply, which I am building at the moment. And after I have made plans, as I said before, we are going to wind the transformer according to the layout on the printed circuit board. Right, this is the layout of our windings. Okay, we're going to have the primary winding here on letter C. We're going to make it center tap, and after we wind the secondary windings, we're going to make the last half of the primary winding here. Okay, I have already planned what I'm going to do according to my PCB, and these are the number of turns that I'm going to have on the secondary, and 30 turns are going to be divided into first half and the second half. 4 turns for the auxiliary A and B, okay, and this is the other auxiliary winding, okay, because this power supply is going to be meant for audio purposes, and I am going to have a dual voltage for the preamplifier and also an outlet for the fan motor. This auxiliary winding here is going to power up the power supply during its operation. In this diagram here, we are seeing how are we going to connect the windings to the pins. Mind you, I am having my center tap here coming out from the top of the transformer, so I am going to use these 2 pins because I will have 4 and 4 wires on each side, and not to have plenty of wires on each pin, I adopted 2 pins to handle the single winding here. And also these represent 2 bundles of 4 wires each that are going to be wired in parallel and wound on the transformer. So I'm going to have 2 here and 2 here. Okay, this is the main output winding. This is obviously the auxiliary for the 12 volts for the preamp. This is the primary winding, which is going to take the center tap over here and finishing at the last pin. And in between here, with pins E, F and G, I'm going to have the auxiliary winding, which will be powering the power supply during operation. The transformer I have here is an ETD 39 from EPCOS, and the core material is an 87. The wire we're going to use for the primary is 4 wires by 0.5, and the wire for the secondary we're going to have 2 4 wires by 0.5. Okay, now as we go along you will understand more what am I saying here. So I wrote down here what I'm going to do. Here this is 15 and 15. Okay, for the primary, the rated voltage here will be 160 volts DC. That would approximately be input of 230 volts AC, and the secondary turns are going to be 909 volts, sorry, 909 turns, and the voltage, the peak voltage will be around 45, 46 volts, okay, with that input. And when the power supply is loaded, it's going to go down to about 38 volts. I forgot to tell you that this power supply is not regulated, so some voltage drop is always present during load. Okay, these are our two auxiliary windings here, which are going to give us 17 volts. One is going to be regulated to 12, and the other will be left open to supply the power supply itself. Right, here I'm showing the twisted wire. This is a 4-stranded wire, okay, which I have twisted beforehand, and they are 4 wires twisted together with a diameter of 0.5. As you can see, it's neatly done, and we're going to use this kind of wire. And you ask me, why are we going to use 4 wire instead of 1 thick one? The reason for this is due to not all the wires can handle high frequencies. Our operating frequency is going to be 68 kilohertz, and the thickness of each strand of wire here can have that type of frequency. I'm going to show some materials that we are going to use. Here I have 2 types of tapes, and I must stress, we always must use heat resisting tape. This is mylar tape, which can withstand temperatures up to 150 degrees centigrade, and this tape does not shrink, does not deform, does not deteriorate. And this is another type of tape, which is also this kind, but this can withstand higher temperatures up to about 250 degrees. This kind of tape is woven tape, okay, which I'm going to cut strips of it to make the margin. Now, what is the margin? As one can see in the bobbin here, the manufacturer has already made a step here so that we can leave some space at the edges. The reason for this is due to have adequate space so the windings will not leak out with each other, and we have to be very careful while doing so. I will show you later while winding up. And the minimum distance is 4 millimeters, okay, but this one has 4 millimeters on each side, so we can have 4 millimeters here for the primary from here to here, and we can also have no distance, no margin at the secondary, because we already have the 4 millimeter from here to here. Or we can have 2 millimeters on each edge, but the secondary must have another 2 millimeters margin, so the total distance will be always 4 millimeters, the minimum. Okay, these are margin tapes that we may be using. It was taken out of an old transformer. The margin tape basically is a heat resisting tape, but it has some thickness, so you don't have to wind a lot of turns to get to the height on the sides, because it has to be level with the windings so that each layer will be nice and flat and not drooping down at the edges. We also have some heat resisting sleeving, alright, and this is high temperature sleeving, which we'll be using at the edges so that we can take out our terminals through it. I have different sizes here. I got the 1 and 1.5 and 2 millimeter sizes, which I will be using when we are winding the transformer. This is our core, which will fit in the transformer, okay, in here. And this is a piece of wood that I have prepared, so that when I put it on my winding machine here, or what you call it, hand winder, this will fit down here, and it has a hole in the middle so it can be rotated on the winding fixture here that I have prepared. Okay, here I got the setup ready. I threaded the first piece of insulation sleeve here, and I mounted the bobbin on the winding fixture here, and I prepared to begin with our primary turns. I have the counter set for 15 turns here, and this will be our start. I'm going to help it a bit at the beginning, so some oil here. There we go. So it will stay rather in place before I start tightening up. Mind you, if you don't have a winding machine, these can always be done by hand. Let's do 3, 4, 4, 5, 6. So we already have 15 turns here. What I'm going to do, I'm going to add an extra turn here because I have space for it. Okay? And the reason for this is that because of the last winding having a larger diameter, so instead of having 15 here and 15 on top, I'm going to have 16 here and 14 on top instead. This will compensate a little bit for the longer wire needed for the second half of the primary winding. It's a practice I have seen in transformers of this kind, and I'm going to adopt it. Right, as one can see here, I have made a couple of strips of the yellow mylar tape, and I also included a piece of insulation here. The reason is I did not go back to the center top here, so I would not have any bulges here as much as possible. So what I'm going to do, I'm going to wind this and leave it here going round until I do the main secondary winding here, and then when coming back to the other half of the primary, I will go back again with the wire without cutting it, and it saves me a bulge here from the wire passing over here, and also it makes the winding better because it will have a tighter coupling with each winding. The next step is, after this, we're going to have 3 layers of tape here now to cover up the primary, because this one is going to carry the mains potential, and the tape has to be have to cover the full width from here to here, so we have a good insulation. Right, we are about to start the secondary winding. What I'm going to do here, because I have calculated that my windings will fit in a single layer for each secondary winding. So I'm going to start from the center top here, okay, and we'll end up on the pins below. Right, so here goes. I'm going to wind this winding with 6 wires side by side, okay, and we are to start right away. So let's turn number 1, turn number 2. We gather the windings together as much as possible. That's 3. Coming up, wait a minute. There is it. It's rather tedious this way because you have to be careful to put them nice and neatly. See if they will fit. The last rev. There we are. Okay, so we have our 9 turns now. Or no, I still have another rev. I have to make them more tightly. Let's check it out. Try to tie them up a bit more. Because of the insulation here, it's pushing the winding sideways. That should suffice. Now, we're going to make the first 3 on 1 pin. I have to choose it to be right. This one it is. I'm going to use the first notch here. And the other one will have to go on this end, more or less. Now I will put a piece of sleeving here again, and we'll go for the next layer. Okay, I've done a piece of sleeving here, and at the moment I am shaving the enamel so that I can solder up the edges, the ends. This is a piece of bent stainless steel which I have sharpened at the edges like this, and it helps me shave the ends. Special care is taken at the very bottom here, because this is where it comes to the pin exactly. The excess will be actually cut off. So at the very bottom I have to shave it properly. Taking another angle here. I have already shaved the other three. Now here I'm going to divide this winding on 2 pins, so I don't have a bulky arrangement here with 6 wires all on 1 pin, because I believe they would be too much. Alright, this is a piece of heat shrink tubing, but now we have to consider that the voltage at this point is not so high. We will cover it with a piece of mylar tape later on while doing the primary winding, just to help it out. I opted for that kind of sleeving for the reason not to be so cumbersome. It's quite heat resisting as well, not as much as the yellow piece, but this will do the job as well. So these are our 3 wires. First we so first we hook up that one. This is not cleaned properly from underneath. I still have to shave it a bit. I can see the enamel there. Let's check the other, they should be alright. There we go again. Get something to push it in there. Fingernail is best. That's one. That's 2. That's 3. Keeping things flat as much as possible here. Help it out a little bit with the pliers just to make it taut. Get the soldering iron and some solder here. I hope it's still in view. Yes, we are. Some flux here. to help me out with the soldering. There it flows. I have a good joint. Okay, I'm going to pause a little bit just not to make the video very long. I'm going to do the other one the same way. Okay, we have to start the other half of the secondary. I started again from the center tab. Okay? Oh, here it goes. Jesus. Let's start again. Thing slipped here. I'm trying to arrange the wires side by side so that they won't be tangled one top of each other. I've got 6 of them here. Quite some hassle, but we'll manage somehow. I got 2 of them are crisscrossing here, look. I'm trying to, there we are. Try to do them as much as neatly as possible. We need tight coupling here, so we don't have a lossy transformer. And we minimize leakage inductance as much as possible. Group them up as much as possible because the space is very limited. Excuse me. This kind of work that takes a lot of patience, but to group up the wires a bit. Still have another one to go. To group them up a bit. Still have the last revolution. This is the trickiest one. done. We get the first three, put in this slot, and the second three, which will be put in the next one. So there we finish the main secondary winding. I will do a piece of tape here, and I just press it down gently. I got a screwdriver with a piece of tissue here, not to dent in any way the enamel of the wire, and lay it down flat. It's not very perfect, but quite close, huh? Okay, I will pause a bit now. I will put some sleeving here and solder the joints together. Okay, the joints are soldered on the other side. Here are the center tabs coming out. It's going to be jointed together. So we have the double winding of 9 turns. Now I am going to wind the last half primary, and after these I'm going to do the auxiliary windings. These are not so important, so they don't really need that tight coupling, but at least regarding the main output, alright, I want the tightest coupling, so I'm not going to do the other windings in between. As one can observe here, I included the margin tape with a height of 1.5 millimeter, as high as this wire is, so that again I will not move more than the allowed 4 millimeter on this side. I have actually around 5 here, okay, but it will suffice for the last 14 turns that I have. Remember that I winded 16 turns in the first half and I wanted 30, so I have 16 and 14 on top. This being a larger diameter, the wire will be somewhat longer, so it would compensate a little bit with that one less turn for the extra length of the wire, so the transformer will be much more balanced this way. Okay, here it goes. I got 14 marked on the counter, so I will be winding the last 14 turns. Small gap here. I made also 3 layers of or 4 layers of tape underneath, because this is going to carry the mains, and we have the 4 turns of the winding. Now I'm going to rest this here for the time being until I get a piece of tape and cover the whole winding up. Okay, so we are at 14. Okay, I have covered the winding in the center with a couple of rounds of mylar tape, but to be safe we have to cover the whole width, so I'm using this tape again, and we are going to cover the whole width of the bobbin with the tape. Having 2 turns or 3, we should be on the safe side there regarding primary winding. Okay, we cut the excess. Put it back. Now all I have to do is joint up the wire here on the first pin, and I will solder the other joint as well. In the meantime, we have to put another 2 windings here. They only consist of 4 turns each, bifilar, and they will sit side by side here. Okay, we'll pause a bit now for the time being, so not to make this video very long. Right, everything is set. I have scratched the enamel of the last of the primary winding here, the last bit, and prepared to wind the bifilar turn for the first auxiliary here, sorry, for the second one, and this is going to power the power supply itself. So we're starting again from the center tap, okay, and we have to wind 4 turns here. So here goes. That's 1, that's 2, that's 3, and this is 4. Right, now we're going to finish with the ends, okay, and we're going to put one on each side here. Okay, I will put a piece of tape. In the meantime, just tie it a bit there, but I wish to put a piece of sleeving as well. A piece of tape here. Should be alright for the time being. This is temporary, so that I can manage the windings without getting untied. Okay, now we take an end of each, slide it slightly back. This one is going to sit over there, and this one will sit over here. We put a piece of sleeving, and we're in business. Okay, I'm going to do the second auxiliary winding here. I already done this one, and I started from the center tap and also put the ends at this side. Now we're going to do this one just the same, and the winding is up to here, so we're going to start beside it. I gave it 3 layers of tape. This one I have to be a bit careful because there we go. That's 1, 2, 3, and this is the 4th turn. Okay, we have to return somewhere here. We tie it for the time being, and we put a piece of tape to hold things together. And our transformer is nearly finished now. Now all is left to do is a couple of sleeving here and finish with the ends, one on here and one on the other side, like so. Okay, I finished the windings here. So I started from the center top here, and then arriving with 2 wires, okay, and then arriving with each end, one on each side. It doesn't matter which way they are, but it would still be the bi-flower winding. Now this is the finishing off with some tape here, just to finish and give it a single color all the way through. Now all there is left is to solder the ends. A good coat of tape here to cover things up thoroughly. Yeah. And our bobbin is finished. This is the center top, which will go on the PCB like this. These are the main windings here. This is one side, this is the other, and these are the center tops for both windings. Okay, and this is the auxiliary here, which is going to supply 12 volts. And on the other side we have the primary from here to here. We made a loop here so not to pass through, but still we have the half of it here, half of it in the very bottom. And this is the other auxiliary, which is going to power the power supply. All there's left now is an insulation test to see if everything is alright. Okay, I have soldered the ends, all of them, both sides, okay, here and the other way as well. And we are going to check the insulation now between the windings all together. Okay, so these happen to be 2 different windings. These are the 2 secondary, the main secondary windings. I'm going to switch the meter on. If I put the probes together, the meter will rise. I have 500 volts present at these probes, and I'm going to check the insulation between the 2 windings. As one can see, it is very high, exceeding 200 megohms. Now I'm going to check between one winding and one of the auxiliary windings here. We still have a very high insulation, as one can see. We are alright. And obviously this is the winding itself, these 2, and these 2 are the other end of the windings. The center top is going to be jointed together anyhow, but it's good to know that you have insulation between windings. Now here, from here to here, we have the main primary winding, okay, and these 3 points are another auxiliary winding, and we're going to check for insulation. The meter hardly moves. Okay. Okay. Now we're going to check the primary winding with the main secondary winding down here. Still very high. And also I'm going to check the auxiliary winding here with the primary, which is also very high. And the insulation check is done. Okay, I'd like to finish my work here with a piece of insulating paper. I prefer this color myself, and I'm going to fix it with some sellotape. I know this is not high temperature, but for this purpose it will suffice. Let me see where we're going to end up. Right, somewhere here. bring it on the side so it won't show the edges. Maybe we start from here like this. That's it. Try to make it nice and flat. And that is our finished job here. All we have to do is assemble the cores now, and we have the ready-made transformer. Right, this is the finished transformer with the insulating paper, and as you can see, there is a gap here for air circulation, and also I made some heat resisting tape here because at times the core tends to get hot. I hope you like the video. Thanks a lot, and thank you for watching.